In this video, we are going to look at custom speech, very similar to the custom image analysis we have done. Image detection, custom image detection, very similar to that. We are going to teach the model something from our data. The model is not aware about something before. We are going to use a very difficult example because the model by default is very good. We are going to use speech to text analysis, and we are going to do custom training. There are different ways to do it. So let's get into the topic. Custom speech is very similar to the other custom training examples we have seen in the case of image as well as language. Basically, we have a model, which is the default model, which is coming with the service or the base model. So we have the base model, which does the default work, and we have some input data we are giving to the model. So this is the input data. In this case, the input data is audio or speech files or streams, doesn't matter, audio information, speech information we are giving, and the output is, as usual, the text. So this is the example we have seen, typical speech to text conversion. Now, the custom part here is nothing but to improve the accuracy of this particular model. For example, this particular audio file has some specific domain-specific words, which is not known to the model. So the model has the capability to take a set of type of files. We'll see shortly. It can take some existing conversions from audio files and text files, corresponding text files. For example, some word, specific word, how that word is spoken. So the speech of that word and the corresponding text we can give as training data. Something like a mapping between audio and text. So like that, you can give many audio and text to the model. Audio and text, like a mapping. So what you're saying is that if this particular audio comes, spit out this particular text. That's what you are telling the model. Another type of data it takes is simply set of some words, simply text. So the idea is whenever the model finds a word within the audio file sounds like this particular word, it will spit this particular text. For example, I can give you a very solid, real example which happened in some of the training. So I had a debugging training in Windows Debug, and the tool is called WinDebug. So I pronounce this as WinDebug, which is common pronunciation for this particular word, but it is written as WinBug or WinBag, or it never really pronounced it like WinDebug. So this word is a short form of WinDebug, at least in my training. At least that's how I pronounce this word in the training. But none of the automated text generation tool from the audio or the auto captioning tool is able to capture this word when I say WinDebug. So for that, we can have something like this. We can give the word WinDebug like so. So that when I say that particular sound, or when I produce that particular sound, it will produce this particular word, WinDebug.exe. So simply text we can give such that whenever the model hear a particular sound, it will check the similarity with this particular word we are giving here. And if it is similar to that word, it will spit that word. Another type of information we can give is the pronunciation. For example, you are hearing WinDebug. So that's what I'm saying. This is what I'm saying, WinDebug. But the text I want to translate, or the text I wanted to come in the caption, is WinDebug. So this is the actual name of the tool. If you want to search in Google, it's fine. You may even find my training as well. So it's a debugger in Windows, which I've created a training. And this is a correct spelling for it. This is the actual word pronounced as WinDebug. So we can tell the model that whenever you hear WinDebug, just give this in the caption or the output text. So that is also possible. So you can have a text to text translation column. So different types of data you can give the model and train the model. After uploading the data into the model, you can train the model just like we do in the case of all the custom models, and create another version of the model, another new model from the baseline, and we can deploy that model. So the whole deployment has a test cycle as well. In the test cycle, what we do is we have a baseline test cases. For example, we got 10% error in the baseline for a particular video file. Say video file 1. So V1. So this is the video file 1. And for video file 1, we got 10% error for the baseline model, the model which we have not yet trained. Now the idea is the error rate. So the error is 10%. 10% words are incorrect for the base model, which is given by the Microsoft without any training. Now we are training the model. We are going to train it using some or the other data. Either we are telling the model, hey, this word is wrong, speak it like this, or giving it some text inputs telling that these are the words you could potentially find in this particular audio files. That's the idea of this particular input. And the idea is to reduce this particular error and using this information, create a better output, something like 3% or better, no error at all. That's the idea behind training with the custom information here, so that the model will produce a text of this particular video or audio file after the training. That's the whole idea. Now, let's have a look at the live example of certain things. We'll have a look at the Speech Studio. So one of the things we are doing slightly differently in this particular exercise is we are going to do this using Speech Studio. We have a session coming up for ML Ops. We'll be using the code in that to do some of these things from code. That's why I'm not showing the Python code for this. But as you know, everything is REST API. You can call from any language, including Python. But we will not be looking at Python code for this particular demo because there is slight amount of complication. Just like all the other custom training we have seen, there are a couple of things to watch and be careful about this as well. So first, let's see a couple of things in the Speech Studio, and then we will see how to do the training. So I'm in the Azure portal and in the Azure AI services. So speech service, I have a couple of speech services created. So you can take any of it. If you want, you can create another one. Just like any other service, not much complications here. So I'm going to click on one of them. And here we can see the Speech Studio. So it'll go to this URL speech.microsoft.com. So in here, we can see almost all the speech services from Microsoft and we can play around it. Speech to text, text to speech. There are different options and permutations and things like that. And in our case, what we are going to do is speech to text and custom speech. This is what we need. Click on it. So these are the steps. It is very well documented here. So evaluate. This is what I mentioned before. We are going to evaluate how much is the accuracy for the base model. Evaluate the base speech to text model with sample audio recordings from your target scenario. So whatever we are trying to translate to text, we are going to see how accurate it is. If you are already getting 99.99 with the default model, don't worry about this whole thing. You can ignore. You already have very good accuracy. No need of custom speech. Now you're getting 90% accuracy. Probably there is a room for improvement. That's where the evaluation comes. You need to understand what you're getting from the base model. Now, once that is done, you can understand. Suppose you have got 90% accuracy or 10% is incorrect. What is that 10%? That is where the defining target comes into the picture. You need to understand what are the words it got wrong. In my case, it was the WinDebug word, the one which I mentioned. So that is a word I want to get it right. For example, in the context of the training is all about that tool, WinDebug. So I want to correct that particular word, and definitely it'll improve my speech to text accuracy in the conversion if I do that. So my target is teaching the model the word WinDebug with the correct spelling. When I say WinDebug, I want the model to type WINDBG. So that is my target in my case. And then using that target, I need to prepare the data. Remember, custom training is all about data. You are going to give some data so that the model can study from that data or custom train the data. So prepare your training and test data sets. In my case, what I'll do, I'll create a document to tell the model that whenever you hear WinDebug, you type WINDBG. So that is my example in my case. And then after that, train the model we'll see a lot of data, different types of data in our examples, so that you will get to know what is the format of the file and things like that. In fact, it is very well documented. We'll check the documentation as well, how those files are created and things like that. And then you can deploy the model and use it like any other model using the endpoint. So these are some of the use cases, terminology, sentence structure, pronunciation, things like that. C3PO, IEEE, there are examples given. So this is the exact same thing I was talking about. So whenever it hears this particular word or letters, it has to spit out this. This is a conversion. Whenever it sees this, it has to spit out this. This is always pronounced as IEEE. I have no idea what this is. I was thinking about that droid in the Star Wars, but it is 3CPO. It's not C3PO. Doesn't matter. This is all about pronunciation. Now there are some other examples here. In fact, it takes a lot of different types of data, unlike the other custom training. So feel free to look at the samples, which I will be uploading to the training data. So there is a very short demo here, and we'll be kind of looking at that particular demo in a bit more detail. So first thing we can do is create a project. So I have a couple of projects created. Let's have a look at some of those projects. So this is a project, and the project has, just like other custom training, the data set, the data to train, and then the training itself, then the testing, and then finally the deployment. Those are the steps we have seen approximately in that documentation as well. Now, these are the data we are having. Let's have a quick look at the data we have. So audio and trans test 1. Let's have a look at this. So this is for testing. This is not for training the model. So very important to understand that. I'll be giving you this particular data. So this is an audio file. This is an audio file, and this is a correct translation of that audio file. This is about some dinosaur or something like that. Doesn't matter to us. It has so many difficult words. If you hear this particular wave or the audio file, you will hear something like this, formerly known as this thing, then this thing, and rest of the things. You can check that file is with you. But the idea here is that this is human generated translation to test the model. So what we're going to test, we're going to give this particular audio to the model and check how many mistakes model is making when we do this particular translation or conversion. So for example, if the model is not getting this particular word right, it means that it needs to study more words. If the model is not getting this word right, again, it needs to learn things. And we will come up with the amount of errors or percentage of error the model is making. That's the whole idea. That is what this particular data is all about. So there are so many files we have uploaded. I'll show you where the files are. Now, this is for testing the model, this particular data set. Now, this is for teaching the model. So there are texts we have given with correct spelling of many of these things. So there are so many texts we are giving to the model, and the model will learn these new words from this particular text. So this is a text, plain text we are giving to the model, no other data. So the idea is whenever the model hears this particular word, it will spit this particular spelling. That's the idea. For example, if the model doesn't know this particular word, it'll spit this particular word when it hear something similar to this particular word. That's the idea all about. So all that special words of this different types of dinosaurs are given in this particular document. These are all dinosaurs, I guess. Not really sure. It's not kind of my domain, but I assume this is about dinosaurs, and it has a lot of different dinosaur names. So that is the plain text data we are going to give. Then there is this document called pronunciation. So pronunciation is, like I mentioned, it's like a key value pair. So first you will have the incorrect word and then the correct word. So let me turn this off so that there is less confusion. So this is the actual file we are giving. So we are telling the model to spit this text when this comes. So this is how it's going to sound, and this is the text we need to spit. So in the output, we'll get this text, and in the audio, we'll be hearing something like this. That's the idea about. So this is kind of the pronunciation of these words. call office is. That's the name of this dinosaur, I guess. Not really sure. Ecastrodon. That's how this is getting pronounced. And similarly, the other word. We have seen that IEEE example in that documentation before. Exact same stuff. So in the example which I mentioned, here the WinDebug will come, and here the spelling of WND debug will come here. So whenever the model hears WinDebug, it'll spit the text WND dbg. So those are the type of text. So I have done some attempts and things like that to test the model a couple of times with slightly different pronunciation and things like that to see how it behaves and stuff. The fact is that in our test cases, the model is very accurate after this particular iteration. So the pronunciation is not making much of a difference because it's already 97%. That's all you can get. It's a very complicated translation. This model is very, very strong when it comes to text to speech. Way stronger than the YouTube captioning, for example. So this pronunciation is not making much difference in this case because it's already accurate after this particular plain text data. We will see that. So those are the three types of data we have in here to train the model and test the model. This is not for training. The last one is not for training, audio plus transcript. That is for testing the model accuracy. That is our benchmark. We assume that this is 100% accurate because this is human generated, and we are going to test what the model is generating and compare it with this transcript. That's what we are going to do in the test phase. Now there are a couple more types of data you can upload. So some of the ones we have seen, then the audio only, you can give audio only. And then the output format. Output format is the way the output has to be displayed. For example, with the correct cases, capital letter for cities and names and things like that. Then the full stop, all that kind of proper texting or formatting. That also can be trained. We will not see an actual example for that, but there are training data. You can experiment yourself. We'll look at pronunciation, structured text, plain text, and audio plus human labeled transcript. That's what we are going to use today. But these are the types of data it takes if you want to experiment it further. But like I mentioned, the model is very strong without any training. But in case if you have something weird like I had, the WinDebug and things like that, you can try something like this. So these are the types of data it takes, pretty much very well documented. So this is the documentation of custom speech. And in the custom speech, there's a section for training and testing datasets. So some of the information about these data is right here. Audio only, some limits are here. Some are used for testing, some are used for training, some are used for both. So have a look at it. So it is a pretty big document. If you want to know more about any of the particular one, you can click on it. It'll go into the same document to the correct place. Custom display text formatting data for the training. So these are some of the examples which is given here for the formatting. And mostly the file formats are given here. These are the file formats. So this is the output we should get. And this is how it sounds. Pronunciation one. So there is a structured text. This is the structured text format. Yeah, this is one of the important documents if you're planning to use this model, how to format the data correctly if you're planning to custom train it. But just the plain text works very, very well. This particular thingy, in my experience, probably that is all you need to get it right. Now, the next thing we are going to do is to train the model. So once we have uploaded the data, so uploading the data is like this. You select what kind of data you're going to upload and click the next button and upload. And next, once you have the data uploaded like this, train the model. I have done a couple of training myself. And if you click on the custom training model, you will get to know what data we have used to train it. For example, this particular model has used this particular plain text, and the other models, for example, this one has used both the plain text and the pronunciation. So you can use multiple files to train the model, multiple data types. That's what we are seeing here. So one thing I would like to mention here is the training is relatively very expensive. So I already spent some 50 Australian dollars just for training these couple of models right here. And it takes a lot of time, like half an hour, 1 hour to train the model, to generate these models. So training is relatively expensive, unlike the other scenarios we were seeing in the case of image and language. The speech custom training is expensive. If you want, put a limit to the Azure budget in case you are on a tight budget, but anything around $50 to $100 you may spend if you're going to do this demo by yourself. So be aware about that before you start doing it. So like I mentioned, click on the model to understand what data the trainee has taken, and these are the custom models it has generated. Now the next step is testing the model, and different error rate we can see here. So custom speech with Azure built-in model, which means that there is no custom training. So this is our benchmark. So this is what we want to improve. So let's click on that. So the first test we've been doing. So there are a couple of important information here to look at. The word error rate. So that is the single most important number we are going to look at. So the idea is very simple. The idea is how much we got it right, how much we got it wrong. In this case, we got it wrong this much percentage of the total words. And what is this model doing? This is the model which being used for this particular translation. And this is the data which is getting translated, the audio trans test 1. If you click on that, we'll go to the same place where we were before. We have seen this data before, that audio files and corresponding translation. That is the test data we are using. And in here, we'll get to know what we got wrong. This is where we can define our targets. For example, in this case, it got these things wrong. So this is the human labeled transcription. So this is the correct thingy or the correct text for the corresponding audio. And this is the one which the model has created, the model 1. This is just the original one. Normalized is more or less the same. Doesn't matter for our discussion. So the model got these words wrong. For example, the model is pronouncing these things incorrectly. I don't know why the model is getting this incorrectly, but these are dinosaur names. That's why it is getting it wrong. So like that, we can see where the model is getting wrong. It's all the dinosaur names and things like that. That blue thing is definitely wrong. It's highlighting the wrong parts. So this is what the default model is doing without any training whatsoever. There are a couple more numbers here: insertion, substitution, deletion, token error rate. It's all different numbers which we can tune and tweak upon from the testing perspective. But I think the most useful information is which are the words we got it wrong, and we can put the correct words in the plain text. And that's exactly what we are going to do next to train the model. So we can go to other test cases. So test 1, let's go to test 1. In the test 1, the error rate is pretty less, from 10% to 3.7%. And the model which we are using is my custom speech model. That's the model we are using, not the base model. Now, my custom speech model, if you go here, this is that model, and we have used only plain text data to get it trained. That's the only data we have used, which is nothing but the name of those dinosaurs. So now the idea is, by the time this test has run, this model, which is a custom trained model, knows about those dinosaur names. Because of that, it is making very less errors. It got that spellings correct. Still, it is getting some of the spellings wrong, but mostly it's doing pretty accurate. There are a few dinosaur names, still it's getting wrong. But this is a phenomenal job by an artificial intelligence model. What I recommend to you is that if you're a native English speaker or something like that, just give this audio to someone you think English know very well. I can bet they will get half of this thing wrong. This model is better than any single human being in translating text. That part I can bet at any time. So these words this model is getting wrong, I don't even know how to pronounce them. So it is doing a phenomenal job, and this text or the speech topic is super complicated. So 3.7% error is a very good number. Now, what we are going to do, we are going to further train the model using the pronunciation as well. The idea is to get these things correct. But for some reason, it's not picking these things very quickly. But in some cases, we are able to get it right to slightly better performance, but not much. In this case, what we have used is both the plain text and the pronunciation. So training for Pro 3. So let's see the model. Training for Pro 3. This is a model. And in the model, we have used both the plain text and pronunciation 3. I have made some changes to this pronunciation so that it'll get at least 1 or 2 words correct. I think it has worked, but for some reason, it's not picking up this one particular word. I don't even know if the speaker is speaking this particular word correctly. It's too complicated even for me, so I can really understand and empathize for the model which is trying to convert this thing. But it's a very hard test we are putting at the model, and this is the test result, and this is the error rate we are giving. So I was testing with different pronunciations. That's why you are seeing multiple different results here with different error rate. Now the final thing is deploying the models. I have not deployed any models. Once you deploy the model, you'll get an endpoint, and you have seen all those things to access from Python and things like that. Not very important. You have seen that a lot. If you want, you can deploy the model and access from a Python or something like that. But this is what you will get once you deploy the model. So it is important to understand this because we will be using this custom speech training part for the MLOps or CI/CD in the upcoming sessions. Before we go, I would like to show you one of the training which I have done to train this model. I was showing you already trained one. The reason I'm not able to do live right now is because it takes a lot of time to generate these models. So what I have done is I have recorded a video and I will just play it. So this is the training video which you're looking at. I'm uploading a data. So right now we can upload first the test data, the audio plus human labeled transcript. We have seen this. And just browsing the file. This file I'll be providing to you as part of the training. And this folder we will have a look before we conclude the session. So in the biology testing training, in the testing, we are selecting this particular file. So I'll show you this file and I'm uploading the file. So the file is uploaded and this is how we got that file. The uploading is still in processing mode, succeeded. We can view the data like this. I have shown you already. So this is the data. We have seen this. If you want, you can play the audio, not a problem, and hear what the audio is talking about. Now we can go ahead and create a baseline, what the default model is going to give. And for testing, we are giving this test data and clicking next. So no training so far. It's all the baseline model. As you can see here, it is the 2024-614. I think it's the date of the model. And you can use that for this particular benchmark. There is no model 2. We are not going to select anything for model 2. Just give any name. Doesn't matter what you give. In this case, I'm just giving some inbuilt model thingy. So click next after the name. Save and close. The testing is happening. Testing doesn't take normally too much time like the training, but it takes time. It's not as quick as we want. Couple of minutes probably. So the testing is complete after a couple of minutes, like 5 minutes or so. So we have seen the output. This output we have seen 10.09. That's the error rate without any training. Now, next thing we are going to do is to upload additional data. In this case, we are going to do the plain text. Again, it is there in the folder, training, plain text. That is the data we are going to upload. We have seen this file. All these files will be with you. If you to refer to the file, one thing to note is this will cost a lot of money. If you're on a budget, definitely make sure that you have enough balance in your account. So we have uploaded the plain text data. Now next is train. Train will take a couple of minutes, probably hours, depends on the data and things like that. In this case, the base model we are selecting is this particular base model. We have selected these items. Going to click next. In this case, the training data we are going to give is the plain text data, not the audio and trans. So plain text data we have given. Then the model name. This is the new model name we have to give. This name you might have seen before, the same model. And again, just verify everything and save and close. So the training will take a good amount of time. And in my case, the training has finished. And next is to test the new model. Again, I'm selecting the same test data. This is our test data. What we are testing with? We are testing with the human generated transcript. This time we will be selecting the model we have just created. This is a model we have just created. And again, another name for the test. So this is a name for the test. Just going to name it test 1 and next, save and close. The test is running again, couple of minutes, around the same minute it is going to take. As you can see, after the training, the error rate has decreased. We have seen this model and the test result before, but the error rate is better in this case. So next is the pronunciation. Pronunciation, as I mentioned, I had to try a couple of things to get a better rate, but it may make bigger difference in some other cases. In this case, we already getting a very good result. So the pronunciation is not going to make much difference. So the pronunciation has uploaded to the data. And again, we are going to train with both pronunciation and the text, the plain text. Naming the model and save and close. Training started with the pronunciation. Again, we got another model and testing the model, exact same process, no difference. And next, give the test name, next, save and close. So test 2 is running. Again, as you can see, the test 2 doesn't have any additional error correction done. In my case, I have done slightly better changes to the pronunciation file and I got a tad bit of advantage in terms of accuracy. But otherwise, the pronunciation file was not making much of a difference. I guess the reason is the base model itself is very strong and it is not able to figure out the pronunciation from the given audio. That's what I understand, why the pronunciation is not really working. So I would like to show you before we go a couple of documents which we have seen. So this is the location of the document. You will see that in your training uploads. So this is the data we have used for training, this particular file. If you open it up, it's just files, MP3 files and WAV file actually, WAV files and corresponding text file. This is the text file. The text file has this format. Then this is the training, the pronunciation one, and this is the file we have seen, the pronunciation one and the plain text file. Then there is this other example. So this is the biology one, which has all the dinosaurs and things. There are other display formatting one. We have seen the other type of data. There is training and testing. Feel free to explore these different training and testing ones. Some we will see in the CI/CD or the MLOps session, which is coming up, but there are other data available in the folder if you want to experiment and play around it a little bit more. And this is the Git URL for this particular topic, sample data, custom speech. This is very sample data for the custom speech. And English US has all those additional things we discussed in the folder. And there are a couple of other languages as well if you want to experiment other languages, but they don't have a lot of different options, but only one option. So we have seen custom speech and we have trained the model in a very niche domain, the dinosaurs. I'm pretty sure 99% of the humans doesn't know how to speak. Probably 99.99% of the humans, normal humans, just like me and you, doesn't know how to pronounce those dinosaur words. But now, after a short training, the model is fully capable of pronouncing or detecting those words correctly. And you have seen the accuracy of the model has increased to almost 100% after the training in a very niche domain. That is the magic of custom training or custom models. We'll see some of them in future as well again. And next we are going to automate this whole thing using CI/CD or MLOps. It's a short form of MLOps. We are going to see a cut down version of MLOps or machine learning operations.